My name is Nick Vasiloglou, and I always wanted to be a rock star. Clearly, I failed. But I live very close with the organizers, and they said, well, we're having an event in October, but we've grown so much, we can't really find a venue. So I said, first of all, they asked me to talk. I said, that's fine. And then I thought, where would be the best place for me to give a talk? And I thought about center stage. So they came, they showed, they liked it. But unfortunately, I made it to the small stage. I didn't make it to the big stage. Last time I was here, it was like a Rick Astley concert. Anyway, so there's a small discrepancy between the title and what we have on the slides. I swear to you, it's a typo. So the concept over here is like answering questions on not multi-million-dollar databases, but multi-million column databases with knowledge graphs. And as we usually disclose when we buy food, the presentation was produced at a facility that LLMs are present. So I also got cut over there. Okay, so there's a bit of LLM in the picture. I know there were a lot of talks about large language models today, so I prefer to talk less about them. So while we're enjoying the advances of generative AI, another revolution and paradigm shift is taking place kind of like silently that I'm not sure that everybody realizes. 10, 15 years ago, when I was actually working with my good friend Ron right across the street, it was the cloud revolution where, the cloud was just like storage and compute, and people were moving all their resources over there. And, trillions of dollars were spent. Companies became super big like Amazon. And the substrate was, basically computers, CPUs on demand and S3 storage on demand. But it seems to me that now nobody really talks about the cloud anymore. Everybody talks about the data cloud. And the paradigm here, the category leader is like Snowflake, where you put all your data over there and you start building applications on top of that. So people don't care anymore about the compute and the storage as is, but they care more about having their data over there and being able to manipulate the data without really having to care about deploying servers and databases and doing all the DBA management. I wanted to make something clear, which I realized I thought it was clear for most of the people, but apparently it is not. There's a big difference being a cloud-hosted versus cloud-native, okay? Still after, 15, 20 years almost since the cloud came up, people still think that, well, okay, that's fine. I can run it on the cloud. I can go launch a machine on Azure, Azure and AWS and do it. But when you are cloud-hosted, it means that when something was built, it was built in order to run on a single machine, meaning that it will have the limited, it could be a very big machine. It doesn't really matter, but you're always constrained by the compute that number of CPUs that this machine has, cores, and the storage. But when you talk about cloud-based or cloud-native, it means that you are built natively on cloud services. You can't take Snowflake and run it on your machine. Snowflake will always run on the cloud because it wasn't designed to be like that. And that means that it uses basically infinite compute and infinite storage, okay? Everything is kind of on demand. You need to run a transaction. There's different billing models, of course, with BigQuery is another, of course, big cloud-native platform. So, if at some point you have a workload that needs 5,000 cores and, 1 petabyte of data, you can just pull your resources, run it, and then shut it down, and then you don't pay anything. So there's a lot of advantages being cloud native. Okay, I'm just keep that in mind. So right now, as I said, there's a paradigm shift where CDOs across the world, they realize that finally you can feed all your databases anything you had all your data into the cloud. Okay, so whether you are a Snowflake or BigQuery, and there's other players, I'm just mentioning these two major ones, you basically have everything in one database. That's like a huge thing. And the next question is that now that an analyst has 100 million columns available that they can access with a select SQL query, well, the next problem happens like, okay, how do I find what I need? I know that I can access it, but it doesn't mean that I can find it. And you might have heard of companies, data catalog companies, that they started doing this work for you, or at least providing the resources in order to do it. And the whole idea is that you start building an ontology, or something that we also call a semantic layer, in order to access it. And I think there were several talks today talking about how you can use a language model in terms of translating natural language to a SQL query that can translate it to a SQL query and find your data. And I believe most of the people talked about the need of a knowledge graph. I'm saying preferably a relational one. I work for RelationalAI, and we are in a new category called relational knowledge graphs, which we'll talk a little bit towards the end. So another thing, like based on what we said right now, that is kind of like surfacing right now, is the modern data stack. So once you have all your data inside a cloud platform, okay, you have ways of ingesting them, transforming them, and then you have all these consumers. You have your BI tools, your notebooks, your ML feature engineering, your data apps that they're looking directly to the database. And it turns out that this is a problem. This is a problem because it creates a lot of noise and a lot of redundancy. Because you might have like an application talking about revenues, having a column name, might be cryptic. Then you might have like a feature engineering talking about the same thing and maybe using a slightly different formula. And in general, if you're just allowing all these consumers to read and write back to your database, you're creating more chaos. What we need, and I think it's becoming the standard right now, you need a semantic layer. So the semantic layer is like this ontology, like this thin substrate that we all agree what the vocabulary is going to be. Okay, I mean, we all have to agree what the revenue is, what constitutes a customer, what constitutes an active customer, and what are their relationships. It's usually something that is humanly readable, and it's quite, concrete and minimal. Okay, so here's the definition we give to an ontology. At least that's how we believe. The ontology is a collection of concepts, relationships, and business rules used by domain specialists in the course of their work. We believe that whether we want or not, every enterprise has an ontology, like every country has a language, a vocabulary. Whether it's model or not, it does exist in the heads or in the invoices or in the applications of the software of the business is running. And a model of that ontology will be familiar to any data consumer on the enterprise, okay? Well, nevertheless, few applications like what we see, and almost none of the enterprise data deliberately conform to that ontology. I probably don't know if we have enough time. I don't want to, spend too much time on that. But concept, what is a concept? Is a subject or object of business utterance, a thing meaningful to business. The relationship is typically a verb, an action, a transition. And the business rule, it's kind of like, whatever a rule is. It's a formula, okay? Like if you are a cybersecurity company, this could be your ontology, like, where you're talking to people. Of course, it's a little bit bigger. I just put a sample, but that's an example. Now, there's lots of benefits by using this semantic layer. It's reusable. It reduces dramatically, I can stress that, the probability of an error. I don't know, if you work in enterprises, how many times have you seen things becoming wrong because, you thought that this column meant that, but it actually meant something else. There's no lineage, there's no provenance. It's very easy to share with people inside and outside of your organization. It turns out that it's very compact whenever you need to write queries, and that's something that we're going to talk a little bit towards the end. Like when you have millions of columns, we have super huge databases, and you have to create a query that traverses, 10 concepts. It's much more easy to generate that automatically, and in a way, it's a much compact way, 10 to 100x in the reduction of the code that you have to write. And of course, because it's, it's another layer, and it has a lot of information, sometimes it's even much easier to optimize the performance of whatever engine is going to execute queries on that. And of course, portability is the other thing. We're going to see that. There's, you have your semantic layer that you can, easily port it from, let's say Snowflake to BigQuery. And, a good indication that this is the way to go is probably the success of DBT. So the DBT is in the form of templatized SQL. There's other frameworks like LookML and Coalesce and Malloy and Prequel that basically, it's a new language, but they translate to SQL. It's a much more compact language, and that has the advantage of portability that I mentioned. And then, of course, there's the old school of the semantic web, Sparkle, RDF, all. They're still trying to get into the game, but I feel like that the modern frameworks have an advantage over there. And of course, there's Goldman Sachs, there's open source Legend, and I think Morgan Stanley has the Morpher, and we do have a language called REL at RelationalAI as well, where basically you can translate to your SQL engine. Okay? Now, it's great. I hope I convinced you why it's good to have an ontology, but the question is, where do you find one? Okay? And I will admit, it is hard to do it manually. Okay? It is also not straightforward to do it with LLMs. Okay? You need kind of like a library of prompts. It's definitely much easier. Okay? So it has lowered the bar. And a hybrid approach, like a human-in-the-loop approach, right now can actually help you, much faster than before, build your own ontology. One of the observations that we've seen when we go to companies that they have hundreds of millions of columns is that 99% of these columns are not really what we call core concepts. They are basically generated. Like if you think at a company, there's a few apps, like your website, customer service app or something else that generates, the core concepts, and everything else is derived from that. So typically, like if you start from the ones that they are the sources, then you can see what your queries are, and then you can automatically start creating, expanding your ontology based on these relationships. The process is simple. You start with the business experts. I think within a few weeks you can have your core ontology, and then the language models can do the heavy lifting, of course, with the human in the loop. And the other thing is, okay, we have the ontology. How do we evaluate it? That's something that you internally have to develop some benchmarks, like, for example, the easiest that everybody's talking. I have a set of 1,000 questions. Given that ontology, what percentage of these questions can be answered automatically, or things like that. Now, this is an example from a customer, and it kind of shows how they started from week 0 to week 23, and they managed to basically translate about 18,000 columns. You see that there's a sudden jump once they start understanding how to do it. And then it actually continues. I just put you the first 23 weeks of working that. Now, and that's without language models. Like now that we're putting language model, that gets even more accelerated. But what is interesting is that as they started slowly and they would see the benefits of the core ontology, now they'd start becoming more invested in that and spending more time and engaging more people to do that because they can see the value. And I just want to give you an example of how what we call semantic search, how like the ontology is helping you answer a question. The idea is that, this is obviously a simple ontology. You have customers, zip codes, CTN is the cell phone number, you have a call, you have an account, and you want to find a cell tower who receives most of the calls from customers who live in a specific address. You can take this graph, you can write it in this relation form, and you can ask it to, here I'm translating it to data log, you can do it in SQL. 3.5 has some problems, GPT-4 does a better job. And a different approach, but the problem with that approach is that as your ontology starts to increase and the queries become more complicated, they don't really fit in the prompt. And we all know that the language models, once you start filling your prompt window context a lot, they start making a lot of mistakes. So a different approach would be to take that query, say, okay, here's my query, here's my ontology. Bring me, you can do it in stages and say, bring me the things that are relevant about answering that query. And then in the end, once you bring those, you go back to your knowledge graph and you can find how you can traverse it, okay? And basically, here it shows the paths that they lead you to the concept that you're interested in. This is, there's several advantages. It requires much cheaper language models that you can deploy, on your premises. And, it's much cheaper. You don't depend on OpenAI or Cohere or whatever, Anthropic costs, okay? And I wanted here to revisit the initial slide where we basically talked about the modern data stack, okay, where we have this semantic layer that helps you basically serve all your consumers of your data. And what I've added over here is something that RelationalAI has done. We are the coprocessor, the AI coprocessor for Snowflake. There was an announcement at the latest Snowflake Summit where basically we embed ourselves, like I talked about the modern, data cloud. It's a big relational engine that can fit hundreds of millions of columns. Now, we go as close as to the core of that. And we're basically, you can think about, managing all these knowledge graphs and all this structured knowledge of semantic layers right in the core, in the security perimeter of Snowflake. There's something called Snowpark containers, which means that your data don't have to go somewhere else and come back. You don't have to deal with your, chief security officer having to do due diligence for another company and worry about all the other problems. So basically, we can do graph analytics, we can do business rules, we can run optimization problems right in the core of your data. And of course, we serve the purpose of creating these semantic paths for feeding your language models and being able to answer your questions. This is some more information. We do support SQL. And with that, I would like to conclude my talk right on time, 3:50.